Hello guys, how are you today? So today I'll be explaining the mechanics course revision question. So let me start with the first one we have on from 1.1 till 1.7. So consider the following quantities below. Which of the following are scalar quantities? Scalar have only a magnitude and no direction. Position can be positive or negative. So that means it is what? It is a vector quantity, right? Distance, on the other hand, is a scalar quantity because it does not have a position, direction. It cannot go positive or negative. It's an absolute value always. Time as well is a scalar quantity as it does not have a direction. And then last but not least, displacement is what is a vector because it has both a magnitude and a direction. Question number 2, grid. An ant moves along a stick at time t0. The ant was observed at position initial 10 centimeter. And then he moves to position 25 centimeter, right? And then he moved to which position? To position -5 centimeters. So what are they looking for? They are looking for the displacement. So what's the overall displacement of the ant? It's delta x, which is x final, minus x initial. So it's gonna be -5 minus 10. So what's it gonna be? It's gonna be -15 centimeters. So we'll move on to section 1.3. So now we move on to question number 3. What does it say in question number 3? It says a truck moves on a straight path from an initial position of 25 meters to a final position of -10 meters during 4 seconds. What's the average velocity? Average velocity is the displacement over the time. So what's it gonna be? It's gonna be -10, which is x final, minus x initial, which is 25, over the time, which is 4. So we're gonna get what? -35 over 4. So it's gonna be approximately what? It's gonna be approximately -8.75 meters per second. So this is the average velocity of the truck. We move on to part B. The truck returns back to its initial position after an additional 4 seconds. What is the average velocity of the truck during the entire journey? Now it returns back to where? To its initial position. So if we're gonna do it like this, it's gonna be x final, which is 25, minus x initial, which is 25, over the total time, which is 8. It's gonna be 0 over 8, which is 0 meters per second. So there is zero displacement, zero displacement and zero average velocity. We move on to question number 4. A particle covers a distance of 120 meters at an average speed of 15 meters per second. Then an additional distance of 200 at a speed of this. What's the total average speed? How do we find this? We know that average speed is distance over time. We can find the total distance by doing 120 plus 200. So total distance is 320 meters. Now the total time can be found by doing what? Can be found by doing the distance divided by the respective speed, so 120 divided by 15, in addition to the distance, 200 divided by the respective speed, which is 10, يعني 120 over 15 plus 200 over 10, we'll get an answer which is what? Which is 28. So now what are we gonna do? We're gonna take the total distance divided by the total time, يعني it's gonna be 320 over 28, which is what? Which is 11.4 meters per second. Now we move on to question number 5. It says a boat traveling along a straight line starts its motion at this. So this is time initial. And moves for half an hour, which is 0.5 hour. At an average speed of what? At an average speed of 60 kilometers per hour. At 12:30, this is time 1. The boat changes its speed to cover 70 kilometers. This is the distance in an additional half an hour, in an additional 0.5 hour. Now, what's the total distance covered during the journey? We have, first of all, that it's 70 kilometers traveled in the second part. In addition to what? In addition to, we have the time and the speed. So we can find the distance in the first part by doing distance is equal to speed times time, so 60 times 0.5, that's gonna be then 70 plus 30, which is what? Which is 100. So the total distance traveled through the journey is 100 kilometers. Now the average speed of the boat between 12 p.m. and 1 p.m. is, very simply, we found what? We found the total speed traveled from 12 p.m. to what? To 1 p.m. Now, the total distance. So now, what do we need to find? We need to find the average speed of the boat between 12 p.m. and 1 p.m. So we have the total distance. What are we waiting for? We're waiting for the total time, which is 1 hour from 12 p.m. till 1 p.m. So it's gonna be 100 kilometers per 0.5 hour plus 0.5 hour, which is what? Which is 1 hour. So it's gonna be 100 kilometers per hour. That's it for question number 5. We'll move on to question number 6. What does it say? It says in question number 6, the position time graph of 2 cars A and B is shown below. Calculate the average velocity of each car in the first 8 seconds. So here, this is the first 8 seconds, and this is the first 8 seconds. We should find what the average velocity, because it's a position time graph, that means the average velocity is what is the value of the slope. So in the first 8 seconds, we'll choose any 2 points. For example, this point over here, which is 0, 8, and this point over here, which is what? Which is 8, 4. And how do we do it? You're going to do y minus y over x minus x. So 8 minus 4 over 0 minus 8. So what is that going to be? That's going to be my bad, minus 0.5 meters per second. Now, for the second one, how do we do it? We need to choose any 2 points. For example, this point 0 minus 10, and this point over here 0 minus 2. So how are we going to find it? It's going to be y minus y. Sorry, this is not 0, this is 8. You're going to do y minus y over x minus x. So now we need to find the slope. How do we find the slope? We do y minus y over x minus x, and we will get an answer which is plus 1 meters per second. Now they said in part B, assume the cars continue moving uniformly. Explain how to determine if the cars ever meet. Very simply, you need to expand the graphs, and then after expanding the graphs, you can determine if the cars will ever meet. So for example, expand like this, they will meet at this point over here. Now calculate the time at which the cars meet. Now there's 2 ways to solve this. The first way is to extend the graph and get the answer. The second way is to do what? We know that they both have what? The same final position, because they will meet, and the same time, because they will meet. So what can we say? We can say that x final is equal to x initial plus velocity times time. Okay, so let's say this is for A. So x final A is equal to x initial A plus velocity A times time, A. And then x final B is equal to x initial B plus velocity B times time B. We know what? We know that the time is the same for both of them, and we know that x final is the same for both of them. So very simply, what can you do? You can equate them. So it's going to be x initial of A plus velocity times time is equal to x initial of B plus velocity times time, right? And now we only need to substitute. So for A, x initial is 8 plus its velocity, which is minus 0.5 times the time. So يعني minus 0.5 t is equal to x initial of B, which is minus 10, plus 1 times t, which is t. So move this to this side, move this to that side. You will get now that 18 is equal to 1.5 t, and then t is equal to what? It's equal to 12 seconds. Now, 3. Determine which car has covered a greater distance by the time they meet. Now, what you need to know that is that the more sloped something is, the greater distance it covers. So in this scenario, between car A and car B has what? Has a greater slope. That means it will cover what? It will cover a greater distance. So that means in this scenario, you can say that car B, because it is sloped more, will have what? Will cover a greater distance. Now we move on to 7 grid. The position time graph of a moving particle is shown below. The dashed line is the tangent to the curve at time equals 5 seconds. Determine the object's velocity at time is 5 seconds. So now, how do we do that? Very simply, you need to take the slope of the tangent. So just to choose any 2 points. For example, I will choose this point over here, which is 5, 5. And this point over here, let's choose a good point. And this point over here, which is 7, which is 6, 7. Haha, very funny, 6, 7. So now we need to find the slope. It's gonna be y minus y, 5 minus 7 over x minus x, 5 minus 6, 5 minus 7 over 5 minus 6, and we will get an answer of 2 meters per second. We'll move now to question number 8. What does it say? It says the diagram below shows the change in position of a swimmer in a freestyle swimming competition as a function of time. She covers the length of a pool within 33 seconds, rests for 1 second, and swims back to her starting point in 26 seconds. So at which point is the swimmer at rest? At which point is the swimmer at rest? At point D, because the slope is 0. In which time interval is her velocity constant and negative? It is from time interval 34, let us say, all the way till 60 seconds. So 34 seconds until 60 seconds. And what's the average velocity of the swimmer in the time interval 15 seconds and 33 seconds? We'll go to 15, which I believe is over here. And 33, which I believe is over here as well. So we'll choose 2 points, these 2 points, right? So at 15, the position is 10. At 33, the position is 40. So how do you find the average velocity? It's the value of the slope. So it's y minus y, so 40 minus 10, over x minus x, which is 33 minus 15. So 40 minus 10 over 33 minus 15, that's going to be approximately 1.67 meters per second. Now the last question. A motorcycle is traveling along a straight road with a velocity of 25 meters per second. The driver presses down on the accelerator and 5 seconds later he's at 35. What's the average velocity? The average acceleration. It's going to be velocity final minus velocity initial over the time. So it's going to be 35 minus 25 over what? Over the total time, which was 5. So it's going to be what? It's going to be 2 meters per second squared. So thank you guys for watching. I hope you enjoyed and have a wonderful